Hello.
Hello.
When will we start?
Yes, sir.
No, no, I am actually a presenter based
Yeah,
on.
yeah. Just actually, I'm waiting for external expert.
Okay.
Just once he's joined, we will start your session.
Okay, okay. Sure, sir.
Yeah, just be ready with your presentations.
Sure, sir. Sure. Thank you, sir.
Okay. Nayan Jadhav. Hello, Nayan Jadhav. Nayan Jadhav is there? Nayan Jadhav. Dr. Aarti. Dr. Aarti.
I'm there.
Yeah, Nayan Jadhav. Yeah.
Yeah, sir.
Can you please start your presentation?
Me, sir.
Yes, yes. Just share your screen and presentation.
Wait, sir. I will start.
Yeah. You just click on share button.
Yeah, sir. Sir, is it visible?
Yes, yes, it's visible.
May I start the
Yes,
presentation?
yes,
Yes,
you
sir.
can start.
Myself, Nayan Chada. I am a research scholar from Karnataka State Akmadevi Women's University, Vijaypura. My paper title is Recognition and Classification of Medical Images Using Convolution Neural Network. These are the content of my presentation: introduction, existing or related work, problem regarding the existing approach, proposed methodology, result and discussion, conclusion and future work. There are some references which I have referred. This is the introduction. Pneumonia is one of the risky disease which is caused due to the green energy content in the pollutions. Like green energy means like wind, sunlight, and air pollution, whatever it is caused. No, due to that we are causing lots of pneumonia diseases. If it is not detected early, it may be caused with virus, bacteria, and other types of germs. If it and even diagnosing the x-ray pictures, it may consume lots of time for the for diagnosing. My research work is to diagnose early regarding pneumonia, and we have to inform that patient have to be what precautions they have to take based on this. I have used the CNN and the pre-trained model for the predicting my disease. These are the some related work which I have referred, like Sorik M and Yang Y, Cherit B and Zhang. These many authors I have referred. They have used even convolution neural network with the chest X-ray image only, and with some only they have used only convolution neural network. Some have worked with the pre-trained model, which they have got 94 accuracy, 94, and some of them are got the above 90 accuracy. These are the some problem existing problem for the approach. There is a lots of there is no there is not proper diagnosed for the pneumonia. For X-ray image, it may take the lots of time, and the early pneumonia detection is necessary for the patients, and the accuracy is low due to the we are detecting with X-ray, so accuracy is less due to that. And this is the my proposed methodology. In that I have used the CNN multi-layer Pristons, where convolution neural network is used for the feature extraction. It's a key point for the feature extraction, whereas multi-layer Pristons are used for recognition, pattern classifications, as well as the predictions. Whereas my methodology identify it's classified into three process, namely data handling, where data handling will be dealing with the ensuring that data which we have used, that we like images or patient details which we have used, that will be secure and safe in the data storage, so we can use whenever necessary for our work. Augmentation, it's having the less data set, so I have done the augmentation, because augmentation is nothing but artificially using the data, means enlarging the data set for the small data set, and I have done the training and testing for the data set, and like removed the retrieved the imbalanced data with a different size. In the three operation stages, where this is the my block diagram of proposed methodology. Input image is given, where convolution layer will be recognize the feature of the diseases where exactly it is caused, and pooling layer will be giving on that features. It will provide the abstract, means what work we have to do, what we have to hide, and whereas fully connected layer will predict the which either person is caused with pneumonia disease or not. This is the my overall block diagram of the my proposed methodology. These are the accuracy I have got nearly 95. In that, this is the my training and validation accuracy. This is the my training and validation loss. This is the my confusion matrix regarding the prediction, and this is the my ROC curve. Training and validation accuracy is nothing but a training accuracy is not how much.
आकांक्षा ने
सर तो ये मैं करवा रही हूँ मैडम से, तुम कर दो, मैं
Hello?
खुद इसके भेजूँ।
कहाँ कर तू
रेड से कर
Hello?
दो।
Hello, Miss Aarti, can you please mute your mic?
Oh, sorry,
Miss
sir.
Aarti?
Yes, sir. May I continue?
Yes, Nayan, you can continue.
Yes, sir. And training accuracy is nothing but how much data model is fitted for the data set, whereas validation accuracy is nothing but how much it is fit for the model, whereas training loss and validation loss is nothing but how much our overall work is fitted for the model as well as the data set. And ROC is nothing but a diagnosis of the prediction. AOC is nothing but a similarity distributions. These are the my overall results of the predictions, which I have got nearly 95%, is 0.944. And overall my conclusion is nothing but I am currently working on the X-ray images using the CNN and convolution neural network, and as well as pre-trained model I have worked. I have got the results of 95%, which is not up to my mark. So now I am currently working on the hybrid models like CNN and with the RNN like LSTM and GRU, and even I have developed the one prediction model on which we can early diagnose of the diseases, and as well as the precautions we can provide them. These are my conclusion which I have worked, and these are the references which I have referred, and thank you. Hello?
Okay, Nayan. So there are some questions from my end.
Yes, sir, you can, sir.
Yeah. So what are the parameters you have used for training, for optimization of the results?
Parameters means, sir, I have not
Means,
understood.
you have trained your model. First question is, how you are basically, which are the tools you have used for training your models?
Yes, sir. Actually, sir, I have used for training model. I have just basis on the CNN only. I have trained, sir. Means like I have used for training purpose.
And what are the how many training data set and testing data sets you have used?
Yes, sir. For training purpose, I have used 4,642 data, sir. In that, 3,418 are pneumonia, 1, 2 to 4 are normal images. For testing purpose, I have used 919, 641 are of pneumonia, and 278 are of normal. For validation, 295 images I have used. In that, 214 for the pneumonia disease and 81 for normal diseases. Total, I have used 5,856 image data sets.
So, then, see, the
Yes, sir.
convolution neural network, if we are using,
Yes,
it
sir.
required huge amount of data, right?
Yes, sir.
But you have used only 900 data set.
Actually, sir, when I started work now, sir, I was not having idea, sir. Means how much data set I have to use for the prediction, that all. So I have worked on small data sets, sir. Now currently I am working on large data set, like 10,000, nearly 10,000 data set I have collected, sir. On that I am working, sir.
And it was surprised that 94% accuracy you have achieved
Yeah, sir.
with that small data sets.
Yeah, sir.
Okay, and how this graph been generated? What are the
Actu-
tools you have used?
For generating the data tools,
This current your screen, I'm just seeing your screen training and validation accuracy.
yeah, sir.
How you have generated this graph?
By using the optimization for the optimizations, like technique ROC, means
No.
that
That is okay. ROC and techniques are the thing you have. I'm just asking what are the tools you have used?
tools actually, sir.
Where you have trained your deep learning model?
Actually, sir, I'm still working on it, sir. I have.
No, that is okay. I just you have told about your training and testing.
Yes, sir.
So somewhere you have trained your model on this particular images, right?
Yes, sir.
Where you have trained your images.
Actually, in coding part only I have trained, sir.
Coding part you have trained.
Yes, sir.
Can you please elaborate on this?
Actually, sir, now currently I'm not having means currently I have not seen that regarding that training and testing clearly, sir, because of some problem. Means it I was having classes, sir, so I have not studied more regarding this, sir.
So this paper is completely written by you, the research?
Yes, sir. Yes, sir.
So, okay, Nayan, thank you. Thank you for the time.
Yes, sir.
Thank you. You can just leave the session.
Okay, sir. Thank you, sir.
Thank you. Next is Dr. Aarti. You can unshare your screen, Nayan.
Yes, sir. I will, sir.
Dr. Aarti, can you please share your screen?
Yes, sir. Just wait a second.
Dr. Aarti, you can start. Dr. Aarti.
Sir, just give me a 5 minutes. If somebody is in the queue, he or she may just present their presentation. I just need 5 minutes, sir.
Okay, we'll wait for 5 minutes.
Okay. Thank you so much.
Just
for your
let me
cooperation, sir.
request Insia Fatima.
Yes, sir.
Are you ready for the presentation?
Yes, I am.
Yes, you can share your screen and can start.
Okay, sir. Okay, sir. Can you see my screen?
Yes, your screen is visible.
Okay, great. Okay, sir. So my name is Insia Fatima, and I'm a master's student, MTech data science student from Emily University, Noida. And the paper which I'm presenting is flame prediction using machine learning to tackle forest fires. So basically, what I'm trying to do here is I am trying to predict whether there will be fires in certain areas of forest. By taking an idea that yes, by taking the factors in consideration, all the features include temperature, humidity, wind speed, precipitation, and all of these. On the basis of all these features, I'm making a machine learning model. Actually, I'm training 3 models together and then printing out which model is predicting better and out of the 3 models which I've used. So as we already know, predicting forest fires is actually a very, very important topic right now. Let me just go over to the outline of this presentation. So firstly, I'll cover the introduction part, which will tell me or tell us that what exactly is the need of this type of topic and why exactly I'm choosing this topic. Then the study area. Study area covers the part of, I have chosen Maharashtra as my study area. So I have specifically chosen Maharashtra because Maharashtra in the last some years have seen a lot of forest fires, and because of that, a lot of destruction has happened to the land. So that is why I've chosen forest fires in Maharashtra. Then third, how did I get the data set? How did I merge and how did I obtain the data set? Finally, the models which were applied. So the total models which were applied were 4 in total. And all the 4 models were 3 models, sorry. First was the K nearest neighbor, second was naive Bayes, and third was decision tree classifier. And then finally, I'm going to analyze and see what are the results of the model and how are they showing accuracy for all of them separately. And finally, the conclusion and references. So let's go over with the first part, which is the introduction. So as I have already told you about it, forest fires is a very, very important topic nowadays because of forest fires itself. A lot of area in the forest gets destroyed and a lot of vegetation gets destroyed. People lose their homes and animals lose their lifestyle is destroyed, ecosystem is disrupted. And because of that only I chose this topic. So as you can see here, according to the Global Forest Watch data, the amount of land lost to forest fires in India has increased by 122% in last 5 years. So we are just talking about India here. In India itself, in the last 5 years, around 122% of forest fires is increased, and because of that the land a lot of land is lost, and which definitely is a huge issue for us because we need land to survive, we need anything to process, and therefore this was a very important topic for us. So objective of my model was I implemented 3 models together, KNN, naive Bayes, and decision tree, and specifically in Maharashtra area. Then the next thing is the study area. So I chose Maharashtra because Maharashtra has a total forest record of 61,579 kilometers, out of which this much 49,546 is the restrained forest and 6,733 square kilometers are saved forest. Saved forest means we have the knowledge about them, and this much 5,300 square kilometers are unclassified. So they haven't classified how many exact amount is there and what which part does it belong to. So I think Maharashtra is a very important study area for us, and I actually went for this because in the last some years there have been a lot of forest fires coming up in Maharashtra area itself. So I actually took this topic because there are a lot of researches done before, but a lot of researches have been concentrated to China and other countries, but not India specifically. And India also, it was not concentrated to Maharashtra, and therefore I took this topic. Then the next is dataset. So basically, I didn't take the dataset from one of the sources. I actually took dataset from 2 sources and then eventually merged them up. I used 2 sources. First was the firms Fire Information for Resource Management System, the firms one. Now this firms provide a data set of whether fire is occurring in a certain day and a certain region or not. Basically, this gives a online data. You can open it right now and we can directly check if there is a fire, if there is fire going on in some specific area or not. So this was providing a real-time data if fire is going on or not, and it also has the previous year data. So I actually got the data for 2019 to 2000. Basically, I took 3 years in total to 2021, the whole year, and then the other was visual crossing weather data set. Now firms was only having latitude, longitude, and date and fire. whether fire is happening in a region or not. And the weather dataset was having all the information about weather, the temperature, the humidity, and everything, including the latitude, longitude, and including the date. So using latitude, longitude, date, and like all of these three columns together, I merged these two data sets to get an idea that in specific day, in specific region of Maharashtra, whether there is fire going on in that region specific or not. So that is how I merged the data. And I have already mentioned here that I have used the data from January 1, 2019 to December 31st, 2021. And the latitude region was 15 degree to 15 to 22, and longitude was 72 to 80, which was the region for Maharashtra. And then finally, I merged these two data sets together to form a bigger data set so that I can analyze myself the features and the factors which will eventually help me to determine if fire is there in a specific region or not. So that is how I merged my data set. Now, the next thing was model deployment. So major part was concentrated. My major part.
Insia, I have one question here.
Yes,
Just can you go to the slide number 5?
yes, sir.
Yeah, the data set, right? So what are the data set? Basically, it is a visual, an image-based data set, or what is the data set?
No,
Set is
sir.
all about?
It's a entry-based data set. It's not image, it's entries. Latitude, longitude, entries, date.
Longitude and altitude.
Yeah.
Okay. So who will be entering this data set? It is a real-time one, or it is a history data?
So this visual cause data set, visual crossing weather data set, that is available online. So what we can do is we can directly go to the website and then directly write the region which I want and the date. They will give us a whole Excel sheet of the data set from this place to this place or whatever we have.
That's see, you're basically just go to the slide number 1.
Okay. 1.
So your topic is basically slide number 2. What is the topic? Basically, flame prediction using machine learning to tackle the forest fires, right? So how basically the longitude and the latitude data sets helps in flame predictions?
Actually, it does not help. I have used that to merge the data set from the firm's department. Actually, a firm was giving me an idea according to the latitude, longitude. Like suppose I choose a region which has latitude say L1 and longitude say L2, maybe. So at L1 and L2, this firm's data set will give me an idea that if fire is going on or not in that region at that specific day. Right. And then the weather data set for that specific L1 and L2 longitude will give me a data that yes, this was the temperature at that specific day for L1 and L2 longitude.
Okay. So can you please tell me what are the major causes of the fire, this forest fire catches? How basically it happens?
Yeah, it is because of very low humidity, and when the temperature becomes very hotter, so that there are 2-3 reasons actually. First one is the man-made, which I haven't covered here because I cannot predict according to the man-made things, which I can definitely work on later. But for now, I have worked on the natural fire processes, which gives you like the major cause being when the leaves turn together, they rub together with each other when there is a low humidity in the region, that starts the forest fires. And because of that, yeah, so I've worked on that.
As I understood from your discussion, you are basically working on only one data set right now. That is about the data which you have. Just can you go to slide number 5?
Yeah, sure.
Yeah, that's about the visual crossing weather data set and the firms, right? Okay. So this about the data set consists of the longitude and latitude and about the temperatures.
Yes, temperature and humidity and all the things related to the weather, all of them with the output file, which was showing that yes, if there's fire or not in that specific day.
Okay, just go ahead. Then I'll ask the question in the last.
Okay, so that is how I merged my data, and that is how I got around for this 3 years, I got around 27,000 entries. So my data points are around 27,000. So I was actually wanted to go for 15,000 plus because that is how it gives, if the number of data points are more, then only it gives more accurate results. So I went for 3 years and I eventually got 27,000 data points. And on that 27,000 data points, I was able to predict, I was able to train my model specifically. So the models which are applied were K-nearest neighbor, because I'm going to classify if there will be forest fire or not. So I am going to use classification models. And the first model which I used was K-nearest neighbor. So K-nearest neighbor is a model which actually identified according to the data set near it, and it calculates the distance. It can be Euclidean distance, it can be Minkowski distance, any distance can be used. I actually used Euclidean distance to calculate the distance in between. I have just deployed the model, and then k-nearest neighbor was deployed according to the dataset which was already created before. Then second model which I used was naive-Bayes classifier. Naive-Bayes classifier works on conditional probability. Conditional probability means like suppose the probability of some event happening on the basis of event which is already happening in the past or maybe already happening right now. So that was the formula. If probability of S happening when the R is already happened is equal to probability of R happening when S is already happening times probability of S divided by probability of R. So that was the formula which is actually used in naive-Bayes classifier. And the third one which I used was decision tree model. So in decision tree model, decision tree is actually a very versatile model. It can be used to predict, it can be used for classification and regression both. I used for the classification part because my model was restricted to the classification purpose. In decision tree, what happens is there is a root node, there are several decision nodes, and then there's a terminal node which actually gives you the output. Suppose I want to buy a car, then my root node will become buying a car, yes or no will be the terminal nodes that I'll help identify if which, according to the conditions below, which will from yes or no will I will be choosing. So that is how decision tree is employed. Finally, I deployed my model, and this is how I got the accuracy and analysis, the results and everything. So when I deployed this model, I actually used the training and splitting data set, and I split for 70% of the data set I was using in training model, and 30% of the data set was used in testing the model. This was there for all the three models, 70 to 30. I actually tried other ratios also, but this ratio was providing me better results, so I went for this one only. Then while deploying the model, I saw that around the model is correctly on the testing data set, it was correctly predicting for 95% values. And then the AUC curve, I actually plotted that out also. That was around 0.85. All the evaluation parameters are already mentioned below: the precision, the recall, the F1 store. For class 0, class 0 was actually the class where there is no forest fire occurring. And class 1 was the class when forest fire is occurring. So that was how k-nearest neighbor was deployed. Then the second model was naive-Bayes. Again, naive-Bayes was split into 70% training and 30% for the testing. This model showed an accuracy of 93.91%, which was also a good accuracy, but it was lower than KNN, obviously. And AUC curve was also, AUC score was coming up to be 0.73. And again, similarly, precision, recall, and F1 score was calculated for both class 0 and class 1. And that is how I deployed the naive-Bayes model. And finally, I went for the decision tree model. So decision tree actually showed the highest accuracy of around 96.32% on the test data set and had an AUC curve of 0.85. And again, the precision, recall, F1 score and support was calculated for forest fire being in their region or not, for class 0 and class 1 specifically. So that is how I deployed the model, and that is how I calculated the accuracy and the AUC curve of the models. Then finally, in conclusion, according to all the three models, I finally got that decision tree was working the best. Decision tree got an accuracy of 96.32%, and then k-nearest neighbor after that, and then naive-Bayes after it. So that is how I deployed my models, and that is how I was able to predict that is there forest fire occurring in specific region of Maharashtra for a certain period of time, or according to their latitude and longitude. So that is how I did it. Now, future work involves a lot of things. I can change the geographical area. I can also try deploying any instant-based model, maybe the model which I am making myself from the scratch, so I can deploy that. So these are all the future work which can be done. And finally, the references at the end. So the references which I used earlier and everything is mentioned. Thank you.
Okay, I have one question.
Yes, sir.
Yeah, I want to know how many instances are there in your data set and how many of them are related to fire and how many of them are related to non-fire.
I actually did some feature extraction. I did. So a lot of if I talk about the columns, there were a lot of columns like wind speed, wind accuracy.
No, I am not talking about the column. I am talking about the rows.
Okay.
Rows. How
Yes,
many data instances were there? How many belongs to fire, occurrence of fire? How many belongs to occurrence of non-fire or no fire?
Okay. So in total, there were 27,000 data sets. In total, 27,700. And for the output being 1 means if I talk about if fire is there in a region or not, it's around, I'll just check it right now. I have the
Yeah,
data.
you can check.
Yeah. So for 1, it was around.
So Insia, I have one question here. So what are the tools you have used for training of your model?
So I have used pandas. I have used all the model implementation.
Pandas is for mathematical tools, right?
Yes. I have used matplotlib for plotting the graph.
Hmm. Okay.
I have also used sklearn for deploying the model. For training and splitting of the data set, I have used sklearn.metrics, which is splits. Then I have used pyplot, which actually helps in plotting the graph for the AUC curve.
And how you have optimized your results? What are the parameters for optimization you have used?
So for optimization, I'm getting the result at the end. So I actually tried
Result
changing.
we have got your result. But what are the parameters you have fine-tuned for optimization of your results? We want to understand the parameters. Okay, what parameters you have used? Like, there are batch size, okay, and the number of training you have taken, testing data you have done, right? And data augmentation technique you have used or not. Okay, this kind of parameters, learning rates, you have increased
I
or
have worked
decreased.
on, yes, sir. I have worked with learning rate also, and I have worked with various parameters, including dropout.
Those parameters we want to understand how you have optimized those parameters, what are the values you have kept, how you have taken those value you have given by your own, or you have just used some mathematical calculation for setting up those particular parameters.
No, sir. I have used mathematical process to set up that parameter.
So what are that mathematical processes you have used?
So I have first of all used learning rate, right? I have also used the Layfed transforming method, which is already there in the matplotlib, right? It is already there in sklearn.preprocessing, the header file which we have, the module. I have imported it from there, and then I have used it. So it's not what I have employed. I have actually used all the mathematical terms which are already there, and I have used that module to predict the result.
Can you show at the bottom your results?
Yeah.
So why you have not used the image data set?
So image data set actually, which was I actually tried to do that, but image was actually showing forest fires occurring in a region. But that image data set was only showing the regions where man-made forest or man-made fires, and both are there, including.
Nothing like that. You can use IoT devices, cameras to capture those kind of fires.
Exactly.
Suppose the size of the fires, flames are very less. Even though a person, if is basically in the fire for just lighting the fire for bonfires or some kind of picnics, so you will be considering it as like the forest fires.
No, sir. Actually, I was trying to say that I have tried doing that, and I will be using that in my future work, where I'll be implementing some CNN models or any neural network models where I can read the data set from the images also.
Because I have a doubt that the data set which you have used, like the locations, the heat, the humidity, the temperatures and everything. So at what particular temperature it catches the fire? 100 degrees Celsius?
Sir, actually, that was trained from the model itself. Whatever data.
Have you not analyzed that particular data set?
Sir, I've seen humidity. If the humidity goes very, very less, then only it's catching the fire. It's not because of it's not just because of temperature rising. It's because of humidity also, and it is because of precipitation.
Can you please show the data set and the headers of those data sets, if possible?
Yes, sure. Sir.
Yeah. So here it is. Latitude, longitude, max, temp, min, temp. So where it is showing that it catches the fire.
So this is the output. 0 shows that there is no fire, and 1 shows if there is, yes, fire is there.
Okay. From the data set, if you can just see the row number 2 and row number 1, row number 3. I think it's have the identical data. right?
Actually, sir, it's for the same day, and a little longitude and latitude is changed. So for a little longitude change, it will be showing fire, or it will not be showing fire. The data will be almost the same because there is, as you can see here, a little data latitude and
So
longitude change.
this latitude and longitude, you are basically sharing the result that the area also in which particular country, state, this
I've
particular.
I've downloaded the data set, and then I have specifically taken the latitude and longitude for Maharashtra region. So these all latitudes and longitudes which are used here for Maharashtra region only.
So this much difference, all the temperatures are basically similar.
Yeah.
The longitude and latitude is being changed and it's catching fire and non-fire.
Yeah, so latitude, longitude is minutely changed. So as you can see from latitude from here to here is minutely changed. It's 6976.
I want to say Maharashtra is a big state, right? In which particular is this longitude and latitude of this particular city or state or this particular region is catching the fire? Because the data set, I'm just saying that everything is similar. Only the change in the longitude and the latitude.
No, sir. As we come down the data, the entries are also changing. But see, actually, why exactly same is, suppose I talk about these two regions. So, or these two regions, it will be having drastic difference because this and this is having a drastic difference of latitude or longitude. The change is there, and therefore the magnitude of temperature and all is also changing. But if we change the latitude a little bit only from 0.0 something, then it won't show that much difference in temperature. Because whether we talk about this area or an area a little longer in the latitude or little away, it will not show that much temperature difference. But in total, you can see there is a lot of change in the whole. And this is the data which I haven't modified. I got this data from Visual Crossing itself, which is actually, so as you can see, there's a lot of modifications and changes in all of the data.
Okay, so my recommendation will be in that case, if you are just trained the model and the output has been generated, you just also show that area within the Maharashtra region. Okay, it will be helpful for everybody in the future to identify that yes, there will be this kind of fire maybe in this particular regions.
I get the point. Yes, sir. I can implement that later also in future work.
So thank you, INSEA. Professor Naveen Kumar, sir.
Yes, sir. Yes, sir.
So do you have any questions?
Actually, I have got my doubt cleared. She has shown in the slide how many instance she have taken. I think she have taken 402. Is it belong to fire or it belong to non-fire?
So
402. Yeah, class 0 and class 1.
Yes, sir. The class 0 means there is no forest fire in that region.
No forest fire. Okay.
And class 1 means the class which is showing actually forest fire is there.
Oh, very disbalanced class actually. Only 402 non-fire and 6,530 fire instance are there. Means it is very disbalanced class.
Yeah, actually, I took the data when I actually went for the news, and then I analyzed that from this year to this year there was a lot of forest fire occurring in that region. And then
there are many strategies for balancing the classes. Have you used them for balancing the classes?
So I actually wanted to work on that later. For now, I just wanted to work on the data set and then deploying the model.
Because this is very disbalanced class. 402 is very low as compared to 6,530. Okay.
Okay, thank you, INSEA. It was nice presentation. So now I request Dr. Aarti, you can just start your presentation.
Sorry.
Yeah, good afternoon to all of you. My voice is audible to all?
Yes,
yes, it's audible.
Okay, sir. My name is Dr. Aarti. I'm assistant professor in computer science department in Bharati Vidyapeeth Engineering College, that is in Delhi. So my topic is paradigmatic approach for network security and preventing intrusions. Basically, the project is to secure our data. As we all of you know that we are using digital conversation rather than the physical conversation. So data is transferred from one place to the another place in the form of Wi-Fi. Basically, we are using the Wi-Fi. So just giving some outlines of my presentations are first, we just introduce our topic. Then second is existing approach and the related work that we have done. And third one is the problem in existing approaches and the proposed methodology that we are just finding out and the result and discussions. And at the end, we just conclude and we just work on the future work basically. And last is the references. So start with the introductions. So in an era of rapid technology advancement, network system security has become a paramount concern. The security of network is hangs on the data it generates with assessments relying on the analysis of security attack data. So basically the inference from the data that we are just collecting of communication between the means transferring the informations. So interference from data means that network security relies heavily on data originated or retrieved from the network system. The second one is the preventative and detections and responses. While the majority of efforts concentrates on threats preventions, detections and response-based system and the strategies are equally essentials. The third one is the efficient network monitoring. It should be important to monitoring the network, whether it is a safe or not. So for that, an incident network monitoring system encompasses lateral agility, availability, uptime, and security for comprehensive intrusions prevention. So the study goal of this topic is to examine network security challenges, discuss effective implementation strategies to reduce the security risk, and the exploring future orientation approach for enhanced security. So this is the basic introduction. So just we are discussing about the what the existing approach is there in the market now at that time. So there is basically two existing approaches, that is SNOD and second one is the NIDS. SNOD is the open source intrusion detections that is used to detect basically the detections key where the information is authenticated, shared to other or not. So SNOT is a popular open source intrusions detection and prevent system designed to identify patterns in network traffic. And recently version of SNOTs are allowed rules limitations at the application layer such as HTTP through service inspectors and stream splitters. So the second approach is NIDS, that is the full form of NIDS is Network Intrusion Detection System. They both are doing the detections where we are lacking. So the aim to detect harmful activity like virus, worms, and denial of service (DOC) attack across the network. And NIDS successful relies on rapid, accurate, and reliable detection, often leveraging machine learning for improved accuracy and reduce false alarms. These are the two basic existing approach that we are used to detect. So these both are doing independent work. They are that NShot works on the HTTP and NIDS works on the virus worms and DOS service attacks. So next come to the challenges in the existing approach, what we are actually facing in this approach, that is SNOD and NIDS. So these are the following challenges. First is false positives. False positives means it may cause unnecessary alarm and resource wastages. Okay. The second one is the scalability. As network traffic volume increase, these can struggle to scale effectively, potentially missing threads in a high traffic environments. And the third challenge that we are facing in the existing approach is encrypted traffic. NIDS face challenges in inspecting encrypted traffic, limiting their ability to detect threats within encrypted communication. Complex rule managements is also one of the challenge that the existing approach is facing, and that means managing and updating rules in S nodes can be complex and time consuming, require continuous rule maintenance. And the fifth one is the resource intensives, that is running NIDS, or when we are using these both two existing approach, can be resource intensive, impacting network performance and requiring significant computations power. And the third one, the last one is the alert fatigue. There are so many challenges, but I include the most one that is frequently just come in our path. Then the last one is the alert fatigue. A high volume of alert can lead to alert fatigue, making it challenge to identify critical security incident among a sea of non-critical alerts. So these are the challenge that these two existing approach is facing. So to overcome these challenges, proposed uh, we are proposed a methodology. This is the concept of confidentially that I need to show you. Basically, there are the two. There is some sender and some receiver. The sender name is Alice, and the receiver name is Bomb. In between these two person, we are sending the confidential data. So in such a sense, we are using two. We are just applying the encryption techniques. Encryption technique is basically the cryptography technique in which we are just sharing one key to both the sender and the receivers. So the sender sends the plain text and it is encrypted and just convert into the ciphertext. Then it is in the back side of receiver. Receiver receive the ciphertext that is already encrypted and take the data and further decrypt the data and convert into the plain text. Here both are using same key. Here the Alice key secretly know only to the Alice and Bomb. So they both maintain the confidentiality of their data what they are going to share. This is the proposed methodology. Here we are doing so many things. First, we just this is the basic an outline of the security requirements. Why we just require the security. First one is the plain text. Plain text is convert into the ciphertext by using the encryptions process. There are so many encryption process are there, and the original text is changed into the ciphertext by the tampered. We can also use the encryption process, or we can also use the tampered. Here are the access server resources, where there are so many unauthorized user and the authorized user. So the access server resource sent to the service server. So there are the two things, that whether the data is authenticated to the user, or it may be any spam, or go to the unauthorized user. If it is authenticated, then user can access that data and provide the resource to the services. Here, if unauthorized users get the service server, but it will no resource service provide. It will only provide by the authentication users. So this is the basic and outline of security requirements. So at the end of the result, what we are going to propose, we are proposing an EAP. EAP, just giving some description to the EAP. EAP is basically the extensible authentication protocol. Basically, sir, it is used to pass the supplicants. Supplicants means when we just transfer the data through Wi-Fi signals, yani Wi-Fi workstation and the authentication server. When we just communicate between the Wi-Fi and the authentication server, and authentication server may be the Microsoft or IAS. So on encrypting data, we are proposed that the EAP, that is extensible authentication protocol, is a utilization to provide a secure mean to transport identify details of network identification. Using this EAP approach, only user with an implementation or password can enter a protected site. These strategies limit the amount of users and assist in preventing network congestion, leading in faster and more secure network that are faster and more secure. So basically, we are working on it. We are working on eight with just add on one. Okay, sir. Just adding some more points in that. EAP is just working on 802.1x port access for just protecting network Viva authentications. So this is the new, we can say that existing approaches are S0 and NIDS, and this one is the new one, EAP, that is Extensible Authentication Protocol that we are introduced. So conclusion of this topic is that this research aimed to uncover vulnerability in network security and explore effective strategies for mitigating security risk. It acknowledges that emerging technique that we are using, that is EAP, adoption of network security monitoring protocols like EAP and machine learning integrated detection system. And the second one is EAP and network efficiency. This is the future work that we are going further work over the EAP. That benefit of extensible authentication protocol for reducing congestion and enhancing speed and security. And the third is hybrid model for scalability, that is potential for scalability hybrid model in a network security for future proofing. So these are the conclusion of this project and the future work that we are all going to work in this three mediums by using emerging techniques, EAP and network efficiency, or hybrid model for the scalability, that we are just adding in networking in the machine learning also. So they are the references that I just pick from several source. So these are the references, and thank you. For any questions and query, you can ask, sir.
You have till now you have not implemented any of the algorithms you have mentioned.
Sir, basically that EAP, we just work on the EAP. There are some of most commonly deployed EAP authentications types that we are working on it. So we are deployed 2-3 EAP authentications protocol, that is EAP MD5.
So
That's on the
EAP,
message.
EAPN is an existing algorithm.
Sir, it's a protocol basically.
Okay, it is an existing protocol.
No, sir, we are proposing this.
Okay, you are proposing EAP.
Yeah, EAP,
Okay.
different deployments, matlab different versions of their in the form of all EAP works in the different platforms basically, na. Some on the transport layer securities, and some of the tunnel transport layer, and some of the flexible authentication via secure tunneling. So there are the so many deployments, some common parts EAP, we are just working on it.
So till now, what you have done in this EAP part?
Sir, we introduced that EAP.
Introduce.
Yeah, and we are just apply on the portal, the portal 802.1x.
Okay, how it is different from other approaches?
Sir, this is more secure. The challenge that we are actually facing in this, this will overlap this. These are the challenge of existing approach, that some kind of false positives, and this the scalability. These are the basically the challenge that, and by using the EAP, we just overcome these challenges, sir.
So any comparison chart you have from the existing and yours, and how yours is more optimized than others?
Sir, it is there, but actually I am not just put in the presentation actually.
Sir, actually, how can we compare if the algorithm even it is not implemented?
Yes, sir. Yes, sir. I definitely understand this point. No? You just need the comparison between us. Yes. You just need to add on this slide also.
the algorithm is not implemented, but you have any model for your algorithm? How will you implement that algorithm, and how it will work? Have you any model for that?
Sir,
Slide number
just
6.
repeat last line again, sir. It's not.
Actually, background sound is coming from
Yeah, yeah,
somewhere. I don't know.
yeah.
Okay, okay. Now, actually, I want to know, you have any model for your proposed algorithm, how it will be work, or how it will means
Sir,
it
there
will
is
do the
not,
end-to-end detection.
and this is not an just kind of model. It's just a protocol, basically, na extensible authentication protocol that we are
Yeah,
just apply on the port.
no, protocol you haven't developed yet.
We
Protocol
we
you
just
have.
apply this on the portal port. Portal port that there are so many portal ports that are work for when we just transferring one information to the another information. So our
So
information go to the portal and we are just using 8
no,
point
no. I am asking, EAP is your algorithm or existing algorithm?
EAP. EAP is the
Yeah.
existing algorithm.
Okay, existing algorithm. I
Yeah.
thought that you are proposing that algorithm. That's
No, no,
why I asked.
no, sir. No,
Yeah,
sir. It is the
I thought.
existing. We are just adding the feature on it to make our secured and authentication way.
Okay, okay, okay.
Yes, sir.
Okay, Dr. Aarti.
Yes, sir.
Thank you for the session.
Yeah. Thank you so much, sir. Can I just stop sharing and just
Yeah,
leave
you can stop
the
sharing,
session, sir?
Dr. Aarti.
Okay, okay, sir.
Naveen sir. Satish.
Yes, sir.
So this
Okay, Ajit. Yes, yes. Okay, okay. Continue.
कितने हो गए इसमें present?
Yes, yes. Okay.
कितने पेपर्स प्रेजेंट हो गए आपके सेशन में?
इससे पहले 3, including this 4.
Total 3 presentation has been done. Nayan Jadhav,
Share me the
Aarti.
IDs. Please share me the IDs.
Okay,
Yeah, yeah, yeah.
536.
I don't know the IDs. Just send me the IDs.
537.
1 minute.
539.
1 minute. 537, 539,
579.
579. Only 3, na?
Yes.
And Naveen sir, rest the 100 not join.
No, rest have not
Yes.
joined.
Excuse me, sir.
Yes.
I am here, sir. Paper ID 569, sir.
569.
Yes, sir.
569. Okay, please continue.
सिद्धार्थ कुमार.
नवीन सर प्लीज एक बार नोट कर लो, दो आईडी आ रही है ना, नोट करके.
सर मैंने नेम नोट किया, मैं आईडी उसके करस्पॉन्डिंग मैच करवा दूंगा. मेरे पास पीडीएफ है.
हाँ. ठीक है, आप कंटिन्यू करो सर.
Yes, sir. I am sharing my PPT.
आप दोनों लोग कंटिन्यू करो. अभी कितने पेपर्स हैं?
It is visible, sir.
हाँ, yeah, visible. It's visible. Continue.
In this research, sir, we proposed a Zen expression-based blood cancer classification model using natural computing algorithm along with deep learning. Here we combined two algorithms. One is deep learning, another is natural computing algorithm to enhance our efficiency. Okay. Firstly, we present introduction. There are lots of data available for blood cancer detection in images, but very few data are available for expression-based tabular data. So, and also accuracy for existing model based on Zen expression data is very less. So we try to create a model for tabular data in terms of numeric, in terms of Zen expression data to identify the blood cell cancer. Here we present, firstly we show you there are two types of images. One is normal blood and another is leukemia. Means normally blood cancer is classified further more types. Mainly we use two types, AML and ALL types, means leukemia and normal blood. Here you can clearly see the first figure is denoted as normal blood, another figure is denoted as leukemia. Here you can find out lots of cells are blast cell. If lots of cell are blast in blood cell, then we consider as this blast cell as a leukemia. And further there are lots of types like neutrophil, lymphocyte, monocyte and platelets. Here you clearly see that if blood cell is completely without blast cell, it is known as erythrocytes, means this is normal blood. If blood is blast, in particular this pattern, this is known as neutrophil blast. If blast cell is looks like this pattern is like this is known as lymphocyte. And there are lots of types in blast cell. So basically we focused on to identify the pattern of data, present gene expression data, to identify the blood cell is normal or is having any type of leukemia, ALL type, AML type. We further not consider further more types like AML, ALL, CML. We just consider for classification, is blood cell is normal or blood cell is having leukemia. Okay. So firstly, here we present lots of survey existing work approaches to find out the best approaches for improve my accuracy for gene exploration. In order to find which algorithm is already used by researcher, which gaps are, which problems are faced by researcher, we have presented here literature survey. And from this literature survey, we find out some gaps, like if we use only any machine learning algorithm or any deep learning algorithm, then model trained properly. But this face some overfitting, means if we use any training data and or based on training data, we identify model, we classify our model, we test our model, then accuracy is good. But if we use another data, then accuracy might be affected and accuracy will be very low. So we use the concept of here feature selection approach by utilizing the concept of natural computing. Here two types of feature selection approaches are presented. One is swarm based, another is natural computing based. Means if we used swarm based, then the processing time of swarm based is more compared to natural computing based. Like according to SM Syed, here he has used PSO and genetic algorithm. PSO is swarm based algorithm and genetic algorithm is natural computing based algorithm. And for classification purpose, they have used support vector machine as a machine learning algorithm. But SM Ayad had attained very less accuracy, and here classification time is very large. So we use just one single approach, which is genetic algorithm in our model, and eliminated the concept of PSO, swarm-based algorithm, because most time is consumed by PSO, because PSO is swarm-based searching mechanism. This algorithm, any swarm-based algorithm, perform based on searching mechanism, and to search any particular appropriate feature, PSO or any swarm-based algorithm takes more time compared to natural computing algorithm. And also, they have mostly researchers have used only machine learning approaches and achieve very less accuracy, not very less, just near to 90 to 88% accuracy. And this is not sufficient for medical data analysis. For medical data analysis, we need to attain maximum accuracy. So here we combined two algorithms. One is genetic algorithm and another is deep learning algorithm to train our model. So here we perform a comparative analysis like feature based MDNN. MDNN means modified deep neural network. Means here we use something extra than deep neural network. Means here we used another approach. These are known as feature extraction. For enhancing a purpose, we used optimized feature based DMM. Here we used genetic algorithm for feature selection. Firstly, we need to upload my Gen expression data. After that, we process some pre-processing step like irrelevant data removal based on similarity, null value removal, and after that, which data we got, we extract some feature like mean, median, mode, extent, how much their range. These features we have used. After that, lots of return feature by feature extraction mechanism. Same to remove same feature, we used feature selection approach by using genetic algorithm based on a fitness function. And after that, combining genetic algorithm and deep neural network, we achieve very good accuracy, F-measure, precision, recall, because we eliminate all unnecessary, all irrelevant feature from my data set. Due to this, we present the comparison of precision, recall, F-measure as well as accuracy with respect to existing model proposed by SM Ayad. And here you can see clearly my precision, my recall, and my F-measure is far better than existing work. Also, accuracy is better. My accuracy is 97.8%, but existing is near to 75%. And here we use this feature: mean, standard deviation, mean, max, variance, kurtosis, skewness, range, and then this feature we pass for DMM for first model. For second model, where we use optimization, we perform selection of feature, selection of relevant feature, which maximize our accuracy. Okay. And in future, we can also use combination of optimization technique to achieve better accuracy. And that's all. Thank you.
Hello.
Yes.
Hello.
Can I?
Yeah.
Yes.
You said deep learning.
Yes.
And is there any algorithms? I mean, what are the algorithms you are implementing in this deep learning?
Here we used RNN, modified RNN, not
Modified.
simple
Sir,
RNN,
you
modified
modified.
RNN.
Okay. Have you done any modifications in that?
We used feature in RNN. We don't need any previous feature extraction algorithm. RNN can able to extract feature automatically, but here we firstly use feature extraction approach. After that, feature selection. When we select particular feature, then we pass to RNN for model training. And
is there any tools are you using in your context?
Sir?
I mean, nowadays this is related to medical field, so
yes,
there
sir.
are many advances applications, websites are there. So
Here
have you taken any references from that?
What, sir? I'm not able to understand, sir.
See, nowadays there are many advanced applications, tools are there related
Yes,
to
yes.
medical.
Yes, but
So
most tools are, sir, image based.
Okay.
And this is not image based. This is tabular Gen expression data based.
Yes, understood.
Okay, sir.
Okay. Thank you.
Can I?
Yeah. Other session chairs.
Okay, sir. Thank you.
Okay, Mr. Naveen. So what are the comparative analysis you have done from what are the optimization technique you have used for optimization of your particular approach? What are the hyperparameters you have tuned for that?
Firstly, here we used for hyperparameter tuning, we compare lots of activation function, which is used by model training purpose. Here,
So what are those activations?
mostly used activation function is RNN. For RNN, we mostly
RNN is an
person used
activation function.
10H. No. Mostly person used 10H activation function for RNN. But here we used firstly RNN. After that, we used
No, I am
sigmoid
having
function.
doubt. What are the activation functions? One is
10H
10H
and sigmoid.
and only two, 10H, sigma. ReLU is not there.
Not need to, because mostly we prefer ReLU in image.
Okay. No, activation function can be used anywhere, either in the text data or a pictorial data or any kind of data. That is
Yes,
an
sir.
activation function.
We can use activation function anywhere, but
Hmm.
for particular purpose, we use other activation function. First, suppose if you used in ReLU, main task of ReLU is to minimize the negative portion, negative edges of any images. Okay, but here we work on tabular data, so we not need to use ReLU.
What is the size of your data set?
I have CSV file, sir.
CSV
And
file.
size of CSV file is near to 136 MB.
Okay. Right. So have you undergone any kind of overfitting or underfitting problems while training the model?
No, sir. To resolve the problem of overfitting, we used here feature selection approach. So we don't face any type of overfitting, underfitting problem.
Okay. Chicken.
Okay, I have one question.
Yes, sir.
You have used deep learning,
Yes, sir.
neural network.
Yes, sir.
Okay, so how many layers were there in the deep learning model?
Here we use total 16 layers, sir.
16
Here,
layers. These
16
are
layers.
fixed
Here,
or you have done any experiment? These are
no,
fixed
sir.
or you have done
No,
any
no, sir.
experiment with these layers?
We fix 16 layer based on tuning, based on fine tuning approach.
Okay. And for what purpose you have used genetic algorithm in this?
For selection purpose, sir.
Okay, only feature selection part is done by the genetic algorithm.
Genetic algorithm.
Okay.
Based on fitness
How
criteria.
many features were there and how many were reduced by genetic algorithm?
Basically, we use total 8 feature. Okay.
8
Total
features. Okay.
8 feature. But after genetic algorithm, we reduces by 2 and only we select 6 feature.
Okay, you have selected 6 feature using the genetic algorithm.
Genetic algorithm.
Okay.
Because
And,
most yes.
Yeah.
Yes, sir.
Yeah. Yes. Say whatever you're saying.
Because mostly feature like mean value, nothing play any role in my feature extraction approach.
Okay,
So we reduce.
There are other feature selection approach also, like information gain or many other approaches. Have you compared with those approaches, your feature selection approach with those feature selection approaches?
Yes, sir.
Have you compared?
Sir, I have compared, but my target is to compare only swarm based and natural computing based approaches.
Okay. That's all from my side.
Thank you, Mr. Naveen Kumar.
Thank you, sir.
Ajit sir, we have done with everybody. Miss Jyoti, until she is not going to present, and Mr. Rinku Singh, Raskin Singh is not joining. Not joined yet.
So how many are left now?
Only one left. He has not joined, and others only 4 has presented.
Oh, yeah.
So
Okay.
shall we mark the Raskin Singh as an absent, right?
Yes.
Okay, thank you.
So if you don't mind, could you send me the ID numbers just in chat box?
Yeah.
That we have done. Okay. Thank you.
537, 539, 569, 579.
Okay, 4 papers. So total 4 presenters.
Yes.
Okay, thank you.
Hello. Hello. Hello.
Yes.
Sir, actually, I had a presentation for my paper.
Okay. Paper ID?
So, paper entry 541.
Okay, just wait.
Can I share my presentation? Yeah. Hope my screen is visible. So, I will be presenting my paper, a survey on
Okay, continue.
cloud computing approaches. My name is Vibha. I am a MTech scholar from Symbiosis. So, first, I will share the introduction of my paper. Cloud computing, introduced as a concept within distributed software architecture, has revolutionized IT by offering online hosting services. It has led to the emergence of new user groups and markets, with data centers worldwide providing these services. Key players like Microsoft's SharePoint and Google exemplify cloud computing applications. Security concerns have played a pivotal role in its growing adoption, resulting in extensive efforts to apply security policies and technologies. This introduction sets the stage for the discussion of criminal attacks on cloud environments, their remedies, and the challenges that cloud computing poses to security. Existing approaches. The study proposes integrating auditing for secure data storage and transaction logs, regulatory compliance, real time compliance, and security monitoring, identity infrastructure auditing, data environment and access management, privacy, availability, cyber threats, legality, and granular auditing in order to achieve big data security. There are risks in existing approaches because of the weaknesses and vulnerabilities in computer technologies, especially those that pertain to sniffing, along with spoofing, and also third party attacks, along with replay attacks. Problem in existing approaches. Cloud computing paradigms are the major culprit behind these hazards and challenges. By exploiting the computational capacity of computer system, criminal take advantage of the flaws in cloud computing models to gain sensitive consumer data. The authority raises the risk that security may be jeopardized owing to the lack of oversight across the authorization parameters, especially in relation to resource application and data access. Lack of operating systems, tools, and bad data format standards are further problems that limit mobility between services, applications, and also service providers. The customer must therefore depend solely on the provider. CC systems architecture can occasionally put user security and privacy at risk. Proposed methodology. The study suggests a new trust function with social aspects to boost the current social secret sharing system. It put forth a special framework for carrying out such privacy aware VM migration correctly. Result and discussion. The paper reviewed the literature on cloud computing security, emphasizing the data security concerns. It highlights the critical importance of network and data security in the cloud computing industry, where the vast volumes of data, including audio, text, and video, are stored. Various data protection strategies, including cryptography processes, block ciphers, stream ciphers, and hash mechanisms, are discussed to minimize threats and risks. The study also dwells into recommend remedies for criminal attacks on the cloud environment. Researchers have proposed strategies like auditing, compliance monitoring, identity management, and more to achieve data security in the cloud. The article identifies challenges and security issues in cloud computing pyramids as criminals exploit computational resources to access sensitive consumer data. Overall, the study emphasizes the ongoing evolution of data security methods in cloud environments, with various researchers exploring different approaches and solutions to ensure secure data storage and transaction in the cloud. Conclusion and future work. This underscores the growing significance of data security in cloud computing, addressing three key security issues. It emphasizes the critical role of data protection and explores encryption methods at rest, in transit, and during utilization. As cloud service become increasingly integral, data security remains a top priority. Future work. Future research should focus on the development and implementation of advanced encryption techniques tailored to the evolving cloud computing landscape. Additionally, the study of novel security measures and real-time threat detection systems for cloud environment is essential to ensure robust data security in an ever-changing digital era. This is my references, sir. Thank you. Can I leave?
Yes, Vibha.
Thank you so much, sir.
1 second. And you said block cipher, stream cipher. So do you know the difference between these two, block cipher and stream cipher?
Sir, can you repeat the question?
So Vibha, so you told stream cipher, block cipher, cryptography. Do you know the differences these two, and where you
No,
are implementing this in your cloud? I
sir.
mean, in your this cloud application.
Sir, actually, I was supporting the research in between the scholars. I was
Okay.
coordinating for the formatting and editing. I'm the corresponding author, so I was sending the paper for publication and coordinating for that. Mostly the research part has been done by the other authors.
Okay. So what part you have done?
Sir, I am the corresponding author and I have done the submission and formatting processes.
Okay. Okay. Do you know the services in cloud computing? Cloud, I mean, like cloud, Microsoft, Azure.
No, sir, actually, I'm just a MTech scholar and I don't have that knowledge.
Okay. Other chairs. Yeah, other session chairs. Yes, other session chairs. Dr. Ajit? Yes. Who are else available? Hello.
Satish sir, Satish Konga sir, are you there? है नहीं sir. Oh, okay. Okay.